We have some action that can changes the state of world. Try to come up with the sequence of action that will lead us to the goal state. Do not need to execute action in the real life while searching solutions. Everything perfectly predictable anyway. This is a sample diagram of traveling on the graph. Search of solution diagram. Search tree diagram. Full search tree example diagram. Change the goal want to visit in all vectors in graph. Need a different definition of search state. Currently A also visited B, C ready. Large number of state n star n multiple n power of 1. Could not turn this into a graph. This is example of full search tree. Key concept in the search. Set of state that can be evaluated. And goal state evaluation as goal state. Every state has a state of action set that can be take, typically defined by successor function, goal function that determines cost of each action or path sequence of action. This is an example of weight puzzle. Generic search algorithm. Free set of nodes generated but not expanded. Uniform search. Given state we also know whether it is goal state or not. Cannot say not goal state look better than another non-goal state. Can only transfer state space blindly in hope of somehow hitting a goal state. This is a sample diagram of breadth first search. Properties of breadth first search. Nodes of expanded some orders in for which they are generated. BFS complete. If solution exceed, no, only will be found. In every node has been his successor branching factor. First to cell depth free size at least. Depth first search diagram. Implement first depth first search. Property of a depth first search. Non-complete my cycle through non-goal states. If solution is found generally not optimal, shallow west. Combining good property of BFS and DFS. Limited depth DFS just like DFA expected never go deeper than some depth. Complete fine shallow phase solution. Space requirement of DFS. Let's start thinking about cost. BFS find shallow phase should solution because it also works on shallowest nodes first. Will often pursue lot of short step first. Similar memory problem as BFS. Searching backward from the goal. Sometimes I can search backward from the goal. Muzzle puzzle, merge puzzle, late puzzle reaches location. Bidirectional search, even better search the both the start the goal in parallel. In the shallow solution and depth D branching factor in B, both sides O B D divided by 2n, making bidirectional search work. Need to be able to figure out whether the fringe is inserted. Other than that, we various kinds of either trees corresponding optimal etc. This is a sample and a repeated state. Repeated state. So far, informed research so far have assumed that no non-goal state look like better than another. Unrealistic. Hysteresis. Non-notion history function Hn gives an estimate of the distance from the non-goal. Grade best first search. Bad example of grade. Let G and B cost incurred already on the path to the expanded nodes of lowest Gn plus H plus F. Admissibility. A historical admissibility never overestimate the distance to be goal. Straight line distance in administration can't help anything better than straight road to the goal. Optimality of goal. If the experiment is admissible, A multiple is optimal in the sense that it have never returned at the suboptimal solution. Proof: let n star be the optimal solution node, perhaps not yet discovered. There must be more. A multiple is not complete. Sample diagram of A. A is optimally efficient. A star is optimally efficient in the sense that any other optimally algorithm must expand at least nodes of A expand. A star repeated state. Identically, the second or third time that we reaches the state, the cost is at least as high as the first time. Otherwise, have to update everything that come after. Suppose n and n comma corresponded to some state n is cheaper to reach, but n is expanded first. One big drawback of A multiple is the space requirement. Similar problem as uniform cost search BFS. IDA star graduate increase the cutoff of this. More about hysteresis. Design hysteresis. One strategy of designing hysteresis: relax the problem, make it easier. The ideal relaxed problem is easy to solve, not much cheaper to solve original problems. Markov operators. We swapped two adjustment line, rotated everything.